This is a demonstration on how to use the GASTEC detector tube system. My name is Paul Crows and I'm with Levitt Safety, and I want to show you how to use the GASTEC detector tube system. So GASTEC detector tubes are available for over 500 different gases. Many of these gases are hard to measure with other instruments, and so the detector tube is a very useful tool in most environmental and industrial environments. The GASTEC detector tube system has over 500 different tubes that are available. These tubes measure the concentration in air right here and right now. The tubes are used because they are intrinsically safe by design, they are pre-calibrated, they are inexpensive to use, they're available for a multitude of gases that are hard to measure otherwise, and it's a very simple device. So let me just explain what we have. First part of the system is the actual GASTEC pump. The GASTEC pump, and we have a small maintenance kit, and we have a instruction manual. So the manual is an important thing to review before you do your sampling. The pump itself is comprised of several different parts. At the front end is the actual sampling tip where we insert the tubes into, and there's a little rubber flange in there. The maintenance kit has got replacement rubber flanges in case you need those. There's a tip breaker at the end where we use to snap off the ends of the detector tubes, as well as a little cover so we can remove any of the bits of tips that are left over. The pump itself has a tube counter, or stroke counter rather, at the end of it. So when we use multiple pump strokes, it will advance and keep track of the number of pump strokes that we've taken. The handle itself has two marks on it. One says 100 cc's, so when I pull the tube out, it clicks into the 100 cc mark. Alternately, if I set it to 50 cc's and I line it up to the red dot on the pump body, it will draw a 50 cc sample. And that's used for doing extended ranges of detector tubes. And then the other thing that you have on the GASTEC pump is a flow finish indicator. So at the end of the handle you'll see a bright white dot. When I put a tube in and I draw a sample, you notice that white dot disappears, and then once the sampling is completed, the white dot reappears and the pump is ready to go. There's a couple of things we have to do with detector tubes prior to use. One is to do a leak check. And a leak check involves using a box of or an unbroken tube, inserting it into the front end of the pump, resetting the stroke counter, lining up the 100 cc mark, and drawing out till it comes to a full click stop. At this point in time we wait for 1 minute, and after 1 minute we can check to see if the vacuum is still intact inside of the pump. And we do that by grabbing the handle of the pump firmly and the body of the pump and giving it a quarter turn, and it should draw the handle back to its original starting position. This indicates that there were no leaks in any parts of the system. If it did leak, you would have to perhaps replace the flange at the end, or perhaps spin open the pump like this, and then use the grease that's in this little container and just re-lubricate the end of the pump cylinder itself. And then you'd want to do another leak check. So the other part of the system, of course, is the boxes of tubes. And like I mentioned, there's over 500 different ones. We're going to use carbon dioxide today, a number 2LL tube. You'll notice on the front of the box it says the range of the tubes and the gas we're measuring. It tells us to store it in a cool place, that there's 10 tubes for 10 tests in the box, and just a warning from GASTEC that these tubes are pre-calibrated for use only with the GASTEC pump. And on the top of the box you'll see the actual valid until date, and that's important to realize as well. So inside every box of tubes, if you pull that open, besides the tubes there are two other pieces of information. One is a little card where you can write some notes on and peel them off and put them on the tube once you've completed your sampling, because the tubes aren't a permanent record of the gas concentration. And then the other is the instruction for the actual detector tubes that you're going to be using. So it identifies the tubes, it identifies the the actual measuring range and the concentration, the color change that occurs, any cross interferences, corrections for temperature and humidity. So it's a very important piece of information in part of your sampling. One thing that the carbon dioxide tube doesn't demonstrate, which I'll show you on the 8LA chlorine, is that you can use extended ranges. Carbon dioxide uses one pump stroke and it's completed. Chlorine uses one pump stroke for a range of 0.5 to 8 ppm. But if I use a half a pump stroke, I can double the range, and I can use a 2 pump strokes to make the range even smaller. So to use the system, I select the tube, I insert it into the tip breaker, and I score one end, snap it off, I score the other end, and snap it off. Now at this point, you've got graduations or concentrations on the tube and a small directional arrow by the letter G. That G should be away from the pump, and the arrow indicates the direction of airflow. And we put the tube in to the flange, line up the arrow so it's pointing toward the tube, line up the 100 cc mark with the red arrow, and then draw a sample. So this sample takes approximately 1 minute to complete. The tube itself is white in color, but as the carbon dioxide comes in contact with the reagent, it begins to turn the reagent a light purple color. So at this point in time we wait and we look for the flow finish indicator at the back to indicate that the pump stroke is completed. And at the end of 1 minute we can take the reading off the detector tube and record it on the small card or sheet of paper here to give us a permanent record. So the pump stroke has been completed. I can take it out of the tube holder. And so my GASTEC tube now reads a concentration of about 1,000 parts per million. So I know with confidence that the concentration of carbon dioxide is 1,000 parts per million right here and right now. And that's how you use the detector tube system. So at the end, this tube is done, and you can dispose of it, and you can do another sample in another location if that's what you want to do. Thank you.